All right, so here we have a couple systems of linear inequalities. What we do is we graph both linear inequalities on the same coordinate plane. And what's going to happen, because these inequalities involve shading, you're either shading above or below each line, you're going to look for an overlap of shading. That will be the solution to the system. Maybe we should have written that into our last video. The solution is going to be the overlap of the shading when we graph. Any point that gets shaded twice, basically, an overlap will be a solution to both inequalities. Okay, so our first inequality, we have y is greater than x minus 2. Let's just identify our key information. We have a slope equal to 1. A y-intercept is that negative 2, so 0, negative 2. We can go ahead and plot those points, starting with the y-intercept at negative 2, and then do a slope of 1. So we're going to go up 1 to the right 1 and fill up our whole graph. Now we have to decide if we're going to draw a solid line or a dotted line. Are the solutions on the line? When your inequality says it's just a greater than, that means solutions are not on the line. So we are going to draw a dotted line. And then where are the solutions? Are they above the line or below the line? So when it says y is greater than x minus 2, the solutions are going to be above the line. So I'm going to go ahead and shade. I hope this works out okay. I'm going to shade above the line right here. Okay, so that's what we did in our last lesson. So now what we're going to do is we're going to add in a second inequality on the same graph. And when we do our shading, any solution will be the overlap of the shading. So our second inequality, our slope is a negative 1. The y-intercept is at a positive 1, so 0, 1. We can go ahead and plot those points. There's the positive 1 y-intercept. Slope of negative 1, go down 1 to the right 1, down 1 to the right 1. Fill up your whole graph, and then do we draw a solid line? Are the solutions on the line as well? When it's a or equal to, that's going to be your solid line, because solutions are on the line also, so we want to include them. And then the shading, it says y is less than negative x plus 1, so that's going to shade below. So if you put your pencil on the line, go straight down, that's the region you're going to shade. Now when I shade this, I don't know if it's going to totally cover up or do like a mix, so let me see what happens. Here I'm shading below. Oh, it did kind of nice. So you can see, it's subtle, but you can see that here's the yellow shading. This was everything above the blue line. Here's my green shading, everything below the red line. And then this is the region right here that got shaded twice. That's the overlap. So this is the solution set. Any points in this shaded region that got shaded twice. If you want to just make that shading a little bit more obvious, maybe I'll just come in with another color just to say this is my solution shading right here. Maybe you could just even, make a note just in case it's not obvious. Those are the solutions right there. Okay, so let's try another one. Again, we kind of lucked out because all of these inequalities are solved for y, so they're just ready for us to graph, which is kind of nice. We have y is greater than or equal to negative x plus 2, so our slope is a negative 1. Y-intercept is at a positive 2. So we're going to go to our y-intercept first, plot your point. From there, do your slope of negative 1, so down 1. Remember, we're always running to the right. You'll either rise up or down, but you run to the right every time. That's going to get us the correct line. Are the solutions on the line? It has an or equal to, so we are going to draw a solid line. And then is the shading going to be above or below the line? It says y is greater than or equal to negative x plus 2, so that greater than tells us to do our shading above the line. So I'm going to shade everything up here. Okay, now our second line, the y, or the slope, is negative 1. The y-intercept is -2. So go to our y-intercept. You might notice these have the same slope, but they have different y-intercepts. So these are going to end up being parallel lines. So there's our -1 slope. This says y is less than. It doesn't have the or equal to, so solutions are not on the line. So we're just going to fill in a dotted line. And are we shading above or below? It says y is less than, so we shade below. Again, put your pencil anywhere on the line, go straight down. That's the side or the region that you're going to shade. So we're shading below this line. And what we're looking for a solution set is the overlap of our shading. So here's an example where if we shade above this red line, and if we shade below the green line or the blue line, and these two lines are never going to intersect because they are parallel, this shading is never going to overlap. There is no overlap of shading, which means there is going to be no solution set. So we will write no solution for this system of linear inequalities. Any ordered pair that would work for the blue line, if I plugged it in and then I plugged that ordered pair into the red line, it would not be a true statement. Any ordered pair from the shaded region of the red line, if I plug it into the blue line, it would not be a true statement. So there's no overlap in shading, so there is no solution.